July 23, 1831. Steele's Tavern, Virginia. Temperature pushing 93 degrees by 10 a.m. Cyrus Hall McCormick walked into a field of ripe wheat carrying something the local farmers had been calling McCormick's Folly for the past 6 weeks. The machine looked like a metal sled had mated with a windmill. 7-foot cutting bar mounted on a wheeled frame. Reciprocating blade driven by a ground wheel through a series of gears and cranks. Divider fingers to separate standing wheat from cut grain. A platform where the cut stalks would fall. The whole contraption pulled by a single horse walking alongside the uncut grain, not through it. Absurd, impractical, overcomplicated. John Steele stood with his arms crossed, sweat already soaking through his shirt. He'd seen Robert McCormick, Cyrus's father, spend 20 years trying to build a working mechanical reaper. 20 years of failed prototypes. 20 years of wasted time and money. Now the son wanted to try. "Your father gave up," Steele said. "Smart man knew when to quit." Cyrus adjusted the real height. His hands were 22 years old but already showed the calluses of someone who spent more time in a workshop than behind a plow. "My father didn't give up. He just ran out of solutions." The crowd that gathered numbered maybe 30 people. Farmers, mostly. A few mechanics from town. Several had come specifically to watch the machine fail. Harvest season meant deadlines. Any day spent testing experimental equipment was a day not harvesting grain. The mathematics were brutal. A practiced man with a cradle scythe could cut half an acre per day. Good rhythm, sharp blade, 12 hours of work. 160 wheat stalks per minute. Bend, swing, gather, lay. Repeat 8,000 times. Steele's farm had 70 acres of wheat. At half an acre per day per man, he needed 140 man-days of labor, concentrated into a 2-week window before the grain shattered in the field. That meant 10 men working 14-hour days. Cost, $2 per man per day. Total, $280. His entire profit margin on the crop. And the labor was getting harder to find. Men were moving west, moving to cities, moving to factory work that didn't destroy their backs by age 40. The traditional harvest system was dying. Nobody had figured out what would replace it. McCormick positioned his horse. The gelding was calm, used to strange machinery. That was important. Spooked animals made testing impossible. 6 acres, Cyrus said. "That's what this machine will cut today." Steele laughed. So did half the crowd. 6 acres, 12 times what a man could manage. The ridiculous confidence of youth. "And if it don't," someone called out, "then I rebuild it and come back next year." The machine engaged with a metallic clicking sound. The ground wheel turned. The crank arm converted rotary motion into reciprocating motion. The blade began to move, back and forth. 40 strokes per minute. Smooth. Controlled. The horse walked forward. The divider fingers separated the standing wheat. The blade cut through stalks 3 feet above ground level. Clean cuts, not torn or crushed. The reel pushed cut grain onto the platform in neat sheaves. The machine moved at 2.5 miles per hour. Someone started counting. 67 stalks cut in the first minute. That couldn't be right. Had to be an error in counting. 330 stalks cut in 5 minutes. The sound was hypnotic. The rhythmic clicking of the blade. The whisper of cut wheat falling onto the platform. The soft crunch of the ground wheel rolling through stubble. Cyrus walked beside the machine, one hand on the frame, watching the blade engagement. Every successful cut was data. Every jammed stalk was a problem to solve. His father had focused on push reapers, trying to adapt conventional harvesting motion into mechanical form. That approach had failed because it required tremendous force to push a blade through standing grain from behind. Cyrus had inverted the concept. Pull the grain into the blade. Let the divider fingers organize the chaos. Use the ground wheel's rotation to power the reciprocating motion. Match the blade speed to the forward speed so the cutting edge struck each stalk at the optimal angle. Physics, geometry, mechanical advantage properly applied. By noon, the machine had cut 2 acres. The platform rake, a worker walking behind the machine, gathered the cut wheat into sheaves for binding. One man doing the gathering work, the machine doing the cutting. 2 people performing labor that normally required 4. But the crowd wasn't focused on efficiency metrics. They were focused on the blade that kept cutting, the wheat that kept falling, the horse that walked steadily without exhaustion. At 1:30 p.m., the blade jammed. Tangled stalks caught between the guards and the knife sections. McCormick stopped the machine, cleared the obstruction, adjusted the height of the cut, reduced the reel speed by 5%, resumed operation. At 3:15 p.m., a connecting rod bent under load. McCormick dismounted the assembly, replaced it with a spare he'd brought. 35 minutes lost. The crowd that had expected catastrophic failure watched a methodical repair process instead. By 6 p.m., 6 1/4 acres lay cut. John Steele walked the field, examining the stubble height, checking the grain quality, calculating the yield loss from shattered kernels. "How much did this machine cost to build?" he asked. "Materials? $75. Steele did the mathematics in his head. His 70 acres needed 140 man-days at $2 per day. McCormick's machine, at 6 acres per day, could complete the harvest in 12 days. 1 man running the machine, 1 man raking. Labor cost, $48. Equipment cost, $75. Total, $123. Savings, $157. And that was before accounting for speed. 12 days instead of 14 meant harvesting ahead of weather systems. Meant cutting grain at peak ripeness instead of rushing through whatever could be salvaged. Meant the difference between profit and loss in a marginal year. "When can you build me one?" Steele asked. McCormick had anticipated the question. "Patent application is pending. Once approved, I'll start production." Word spread through Rockbridge County like wheat rust. The McCormick boy had built a working reaper. Actually worked. Cut grain faster than any man with a scythe. Didn't need rest. Didn't need water. Just oiling and adjustment. The patent arrived in June 1834. United States Patent Number 8277X. Improvement in machines for reaping small grain. 7 pages of technical drawings. Reciprocating blade. Divider. Reel. Ground wheel drive. McCormick built 7 machines that summer. Sold them for $100 each. Farmers who bought them harvested twice as much grain as their neighbors using traditional methods. Farmers who didn't buy them watched their harvest windows compress as labor became scarcer and more expensive. By 1840, he'd sold hundreds of machines throughout Virginia and into neighboring states. By 1847, he'd moved operations to Chicago. Central location, railroad access, proximity to the expanding wheat frontier of the Midwest. The McCormick Harvesting Machine Company built 4,000 reapers in 1850, 15,000 in 1856. The machines evolved. Self-rake mechanisms replaced the platform rake worker. Binder attachments tied cut grain into sheaves automatically. Larger cutting bars handled 8-foot swaths instead of 7. But the fundamental design remained unchanged. Reciprocating blade powered by ground wheel. Divider fingers. Reel to guide grain onto the platform. What the farmers understood but couldn't articulate was this. McCormick hadn't just built a better tool. He'd broken a constraint that had governed agriculture since the Neolithic Revolution. Human muscle power limited how much grain a single person could harvest. That limit determined farm size, population density, urban growth potential, and food costs. The mechanical reaper eliminated the constraint. A farm that previously required 10 men at harvest now needed 2, which meant 8 men available for other work, which meant farms could expand beyond the labor capacity of a single family, which meant commercial agriculture at scales previously impossible. By 1860, mechanical reapers had cut the cost of harvesting wheat from 20 cents per bushel to 3 cents. Wheat production increased from 85 million bushels per year in 1840 to 173 million bushels by 1860. The surplus wheat fed eastern cities, financed railroad expansion, provided export income. During the Civil War, while Confederate agriculture collapsed from labor shortages, northern farms maintained production using mechanical harvesters. Men went to war. Machines stayed in the fields. The Union harvested enough grain to feed its army and its cities simultaneously. Food as strategic advantage. Cyrus McCormick died in 1884. His company had produced 500,000 mechanical reapers. The design had been copied, modified, improved by competitors like John Deere and International Harvester. But McCormick's 1831 prototype remained the foundational architecture. That metal sled contraption they mocked in John Steele's field had generated a fortune estimated at $10 million. More importantly, it had restructured American agriculture completely. Modern combine harvesters still use McCormick's reciprocating blade principle. The cutting bar on a 2023 John Deere X9 1100 runs at 3,760 strokes per minute instead of 40. Cuts a 45-foot swath instead of 7 feet. Processes 8 tons of wheat per hour instead of 6 acres per day. But the physics are identical. Reciprocating knife, divider fingers, reel to guide grain, ground wheel drive converted to cutting motion. The machine they called impossible in 1831 became the template for every grain harvest worldwide for the next 194 years. McCormick understood something the skeptics didn't. The problem wasn't building a working reaper. Dozens of inventors had built working reapers. The problem was building a reliable, affordable, repairable reaper that a farmer could operate without specialized training. Every previous design had been too complex, too expensive, or too fragile. McCormick's design used simple components. Farmers could maintain it. Blacksmiths could repair it. The reciprocating blade was intuitive, basically a mechanized scythe. The ground wheel drive meant no external power source. Pull it with a horse you already owned. Practical engineering, not elegant, not sophisticated, practical. And that practicality transformed civilization. Before mechanical reapers, 75% of the population worked in agriculture. By 1920, 30%. By 2020, 2%. Those freed workers built factories, staffed offices, conducted research, wrote novels, taught schools. The industrial economy required agricultural productivity that exceeded basic sustenance. You can't build a technological civilization if everyone is cutting wheat with a scythe. If this story reminded you why agricultural innovation matters, hit that like button. We're documenting the machines and the people who changed civilization with steel, gears, and determination. Subscribe if you want more stories about inventors who ignored the skeptics and built it anyway. Drop a comment and tell us where you're watching from. Iowa? Illinois? Pennsylvania? Maybe Ontario or the UK? Our community spans every place that grows grain. Tell us if you've ever operated vintage harvest equipment, or if your family farmed before combines became standard. Let us know you're here. Thank you for watching, and thank you for making sure Cyrus McCormick's story doesn't fade into silence. These innovators deserve to be remembered. You're helping make that happen.